We rolling? Welcome, everyone. If you're here for the Neutron session, you're in the wrong room. Today we'll be going over kind of an OpenStack Summit primer. The reason why I'm doing this, just for a very quick explanation, is I've been coming to these summits since about 2013. And I remember my first time I came to a summit, I looked at the summit schedule, and I was like, what? What is Project Nova update? What is Swift? I don't know these words, right? I knew what OpenStack was, I knew what it did, but I didn't know what a project update was. I didn't even know what a project was. I went and I sat in on one of these sessions, and they're talking about live migration and the Oslo communication construct. It wasn't proper, and in this Python routine, and I'm like, whoa. I'm just trying to build the thing. I'm trying to get it out of a lab. I build it on my laptop in a VM. I just need to know more. So after many years of doing very technical presentations, I decided I want to give back. And I've been doing these for a couple of years, and I'm glad they put this as like the first session on a Monday, so that we can go through this. If you know OpenStack, some of this is going to be review, maybe some of this is new, but it'll get you jump started for maybe looking at your schedule that you've already picked and saying, I don't think that I want to go to that, or yep, I'm on track. This is me. There's some words, things that I've done. Okay. Why cloud? Why did we even go down this route? Why aren't we just running on physical servers like we always have? Why did this even come about? Why is even OpenStack important? Everything from that point, from the point that cloud as a concept on mid-range servers, not cloud on mainframes, but cloud on mid-range. Once this all started, it started back with Rackspace and AWS and Salesforce. Everything started to change, and we had Web 1.0, we had Web 2.0. Things needed to be processed differently. The velocity of innovation was changing. Static web pages gave way to widgets. Widgets gave way to dynamic web pages. Dynamic web pages gave way to HTML5 and integrated databases and integrated scripts and JavaScript and Java. And to be honest, the days of the truck roll of physical servers and procurement and waiting for them to arrive so someone could load your OS on and someone can put the middleware on it, and someone can secure it, and someone could then approve it, and then it could go for more approvals, and you're looking at your calendar, and it's 55 days later, and all you wanted was another server, right? Your competitors, who were 2 weeks faster at this, were beating you. Well, as cloud came about, people were getting servers in 1 day, 5 days, 10 days. Meanwhile, you're still messing around getting them offloaded on the truck. So when I say cloud, what's the real value of cloud? Is the value of cloud having a GUI to provision servers? That's not the value. Is it that you can meter it? That's not a value. The value of cloud computing is what you get out of it. They have Gartner came up with this kind of graph thing here. And on the outside are all of the requirements for something to be a cloud. Metered usage, service-based, shared services, scalable and elastic, and reachable by internet technologies. And like I say here, the value of cloud computing is what is the value you derive from it. So faster to market, more efficiency, no wasting of resources. Just like an elliptical. I mean, I don't know about you guys, but when I get on an elliptical, which you can tell is not much, but when I do get on an elliptical, I don't do it just to flail my hands and do this motion, right? The value's not in making me really good at doing this, right? It's heart health, it's weight loss. That's the value. So when I say cloud, what is cloud? What are the types of cloud? Well, there's four types or four modalities. IaaS, infrastructure as a service, which I'm sure most of you are pretty familiar with. The VMs, or in AWS's case, EC2. Full machine images, full OSs, and provide you with the ultimate in flexibility. I'm sorry, private cloud. On the next slide. Private cloud. So private cloud is one that's hosted in your enterprise, or one that's hosted for you that's dedicated just to you. Public cloud. Public cloud is hosted somewhere else other than where you are, and it's usually employed with a pay-as-you-go metered billing model. Think AWS, think Google Cloud Platform, think Azure. Multi-cloud and hybrid cloud, and a lot of these get conflated with each other. People say, I'm running hybrid cloud, and I say, really? Tell me about it. Well, I have web servers in Azure, I have web servers in Google, and I have web servers on my OpenStack cloud. Okay, are they interacting with one another, or any of those services interacting? Well, no, they're just in bunches of different places. That's not hybrid cloud. That's multi-cloud. Using multiple clouds, same workloads, but multiple clouds. Hybrid cloud is a mix of public and private cloud, but it's orchestrated together. So let's say you have your web front end in Google, and then you have your app server, well, I don't know why you would do this, but you have your app server in AWS, and your database back on your OpenStack cloud. And you've orchestrated this workload for whatever reason to be interoperable between those three different clouds. So you might say, well, Ben, that's also multi-cloud. You're right. So hybrid cloud is multi-cloud, but multi-cloud is not hybrid cloud. Clear as mud? All right. Now, what I was trying to start earlier. There are many different service models under these types of clouds that get offered, both public and private. Private is kind of listed on top here above the dotted rectangle, and then hosted is down below. There are some exceptions, but we'll keep it separated that way. Infrastructure as a service, we're talking our OpenStacks, our VMwares, our Azure Stack. And again, examples of this in the public sector, public cloud sector, is AWS EC2, GCE, Azure VMs. And I'm not going to go down through all of these and read them all to you, but the container platform, obviously you're hearing a lot about Kubernetes nowadays and Docker. Again, those are some of the private options and some of the public options. Application platform, PaaS. This used to be the biggest thing right after OpenStack came out, after IaaS, was PaaS. And it's fairly big now with products like OpenShift and Cloud Foundry. On the next slide, we'll show you what the responsibilities matrix is of a cloud provider versus a cloud consumer in all these different service models. But it's basically providing you with the development environment instead of giving you the full-blown OS. Function as a service, again, there's quite a few different options there. Probably the most popular one that's out there is Lambda, AWS Lambda. And again, we'll talk about the responsibilities matrix, but the responsibility of the developer with function as a service is basically just the actual function code. The runtime environment and everything below that is part of what the provider gives you. In the case of Lambda, it accepts, I think, 7 different languages. You put your program code in there, hook it up to an API, and it performs a microservice or a function. Every time you hit it, bam, bam, bam. Maybe just telling the time. It'll just return the time, return the time. Very, very abstracted. And as we go through these, you'll see different levels of abstraction. And then when we get to software as a service, think Office 365, Salesforce, things that you don't do anything with, you just consume it. On the private side, you load those applications and you have your customers consume it. And then again, on the public side, you have Oracle, SAP, and Salesforce, and Office 365. So let's just think about this. You know, we talked about as a service models. And if you look to the far right, it's got the actual computing terms there. But if you think about it as pizza, right? So originally, there was no delivery. You just say, hey, you want to get some pizza? And they say, yeah, meet me at Joe's Pizza Shop. And you guys brought your own conversation, you brought your own friends, you brought your beer, you brought your pizza, you know, that you brought the fire. I'm sorry, not Joe's Pizza Shop, at Joe's backyard. And, you know, you you brought all your own supplies. So you had a like pizza cookout before there were even pizza shops, homemade. That's your traditional on-premise. Communal kitchen, which would be infrastructure as a service, you go to a place that it's like a Mongolian grill though, but for pizza, right? So you don't have to bring the oven and the gas, but you bring all your other different materials to build your pizza. So you still have all these responsibilities to bring for this pizza party. Bring your own in containers as a service. Well, they bring the fire, they bring the oven and the electric and gas, but you still have these certain items that you have to bring. Your runtime, your scaling, your functions, and your configuration. And then takeout, they call it takeaway. All of these things are included, right? So they've cooked your pizza, put it in the oven, they're responsible for the temperature, they give you the pizza, and then you bring your own friends with the beer and then the conversation, and so on and so forth. So the layer of abstraction gets less and less as you move towards software as a service. And again, if you're technical minded or want to think of it that way, on the right is the things that become less abstracted, and then of course we have the pizza if you want to relate to that. So what is OpenStack? How does it fit into this? We've talked about cloud, so what is OpenStack? OpenStack's an open source software for building clouds. It's got programmable infrastructure that allows users to have one platform for virtual machines, containers, and bare metal. And hundreds of companies, tens and thousands of individuals, and lots of different companies have come together to create OpenStack. It was a community effort, and it has a ton of projects under its name. But the most important part of this slide is that it's one platform for virtual machines, containers, and bare metal. People tend to get one of these stuck in their head. They say, well, OpenStack's just for VMs. That is not true. It's for VMs, containers, and bare metal. Why does it matter? Why does OpenStack being open source matter? Well, you get choice and control, your ability to switch between vendors. You can take control of what you use. You can bring third-party plugins into it. You're not IP locked. You have your ability to contribute directly to the roadmap or to the projects. So if you don't like something, or you think that it can be improved, or you want to suggest something or add functionality, you're free to do that. Try that with some of your other platform vendors, your infrastructure platform vendors. Try sending a bit of code to Amazon. See what they do with that. I can tell you where it's going to go, into the ether. It's all open source APIs, so that are widely adopted for infrastructure as code, for container deployment, and it's part of a vibrant community, which is everyone here. Whether you know it or not, by even being here, you're part of the community. The community is run by the 4 opens: open source, obviously we know what that is; open design. When things want to be changed and a design change happens, it's posted for everyone to see. Open development. OpenStack is developed out in the open. Code is submitted and reviewed by people just like yourself. Go on, you look at the code. If you don't like it, if you feel that something's wrong with it, you can reject it. And the individuals that write it have to answer to that. And the open community. Here we are. We're not hiding in an office somewhere with a core team that's building this. It's an open, vibrant community. Why do people use OpenStack? Number one reason in the last user survey was operational efficiency. 94% of users said it was their number one business driver. To accelerate innovation. We talked before about having problems provisioning infrastructure for development. Nothing accelerates development more than I need a server or I need a VM now. Well, old way, send a request to the VMware administrator. He'll get to it. Oh, by the way, he has a 10-day SLA, and he's on his coffee break. And he's going to print out your request and then walk it to his desk and then sit down and then type everything in. You should have it in like 9.5 days. I mean, imagine in today's world if we said that to someone, to a developer, right? 9.5 days till you get a VM. They're going to say, what, everyone going on vacation? Is the cloud down? What's going on? And 3, avoid vendor lock-in. Downloading trunk, the trunk release of OpenStack, of Stein, you can put that trunk release in yourself. There's no vendor that's going to tell you, no, you can't do that. You can't run OpenStack that way. You can do whatever you want with it. If you want to go with a distribution, you can go with a distribution. But at the same time, you can work with them or work alone to contribute code upstream. And eventually, your code will make it into the commercial distribution. So, and again, I don't know how many of you attended Upstream University, but there are programs out there that help you get your code into the code base, and it becomes part of OpenStack. That's a very unique thing in open development. There's code that you put in that actually goes into the code bases for Canonical, Red Hat, Mirantis, SUSE. Which industries choose OpenStack? Not many. Just all of them. Retail, financial, telecom, academic, energy, manufacturing, entertainment. And this is just a smattering. I'm sure you've seen during the keynotes, they've put a lot of logos up. The newest adopters from 2018 were those on the far right lower corner. But those are just some of them. And those are some that that I know about and the OpenStack Foundation knows about. There are people that are adopting OpenStack that never tell us, never tell anyone. They just do it, right? I'm sure some of you here, I've never heard of your companies, and you're going to be adopting OpenStack. Until you come to one of these conventions, summits, and tell us, we don't know. So please come and tell us. That way we know who's doing what. What runs on OpenStack? I'm not going to read these out to you. I would say take particular attention to CERN and Walmart. These guys are in a battle for most cores. CERN's well beyond 300,000 cores of OpenStack now. So, and again, I don't want to set up this competition between the two, but they both have massive clouds. And again, this is just some of the companies that are doing it. I couldn't even imagine listing them all. Brief history of OpenStack. 2010, NASA was working on Nebula, and Rackspace had their own cloud orchestration software that they were working on. And sometime in 2010, I don't know exactly the date, but Jim Curry of Rackspace reached out to Chris Kemp at NASA and said, hey, I hear we're working on similar things. Maybe there could be a synergy between us. Maybe we should get together. And they did, and they got together. And by 2012, the OpenStack Foundation was founded. NASA brought Nova, which we will learn a little bit later is the compute project, and Rackspace at the time brought Swift, which is the object storage. They collaborated, and then in 2010 there was the first summit, like you're sitting at here. So 9 years ago was the first summit. It was in Austin, and it had 75 people total. By 2016, back in Austin, it had 7,500 people. So you can see the growth of OpenStack. The OpenStack community is, as I said, very large, very rich. 70,000 members, 185 countries, and 650 organizations. Here's the fairly recent releases. Here's what we've had. Stein was released this month, and Train will be our next release in October of 2017. So when I say trunk or do it yourself, what's the difference between them and these different distributions? Basically, when you download OpenStack from the GitHub and install it yourself, you're doing it with your own support and your own installation tools. And there are plenty of choices out there for installation tools. I encourage you in this summit to check out Airship. Very, very interesting project. But each one of these distributions has their own installation tools and their own opinionated architecture and their own configuration management. And these are things that you get when you get a distribution. I'm not recommending any of them or all of them. These are just some examples. Under the OpenStack Marketplace, you can find others, maybe some that are even appliances. But these give you someone to call if you don't have a big staff or people or the budget or the ability to hire a number of OpenStack professionals or build them in-house. These folks will get you going with their distributions. There's another option, remotely managed OpenStack. So not only will these companies put OpenStack in for you, but when they're finished putting it in and building it to your liking, they will take over and do the operations on it for you remotely. And there are all sorts of different caveats with each one of them, but these are just some of those that will do that for you. So there really should be no excuse for anybody to say, I can't run OpenStack because it's too hard to install, too difficult to run, takes too many people. None of those things are really logistically valid anymore. If you just don't have the desire to run it, this is a great resource, these distributions. So the OpenStack Framework. So a common misunderstanding is that OpenStack is a thing, is a one model of a thing. And it's not. It's built by a bunch of projects that work together to provide you with different services. I'm sure you've heard of as a service model, containers as a service, database as a service. These are things that are delivered by OpenStack projects. It's nearly 60 or possibly more now. I haven't counted them lately. But it all depends on what you need and what you're building your cloud for. If you don't need containers as a service, then you don't need to enable that service. It allows you to, like building blocks or bricks, put together exactly what you need. This is the project navigator on OpenStack.org. I encourage you to go there and look at that, and it'll tell you what each one of the projects are and how to put them together, and it even has some examples of sample architectures. This is the current landscape of projects for OpenStack. And as you can see, the ones that are in bold are the core projects. Core projects are those that kind of get you started, that are the basis of what the basic services for OpenStack: computing, network, storage, whether it's object or block storage, authentication, image management. So those are the ones, and orchestration in the case of Heat, and of course in the case of Horizon is the OpenStack dashboard. But these are the things that make up the core functionality of OpenStack. But as you can see, there's plenty of them that are not bolded. And they all, and again here they list kind of what their functionality is. They all provide a service of some sort. So if we have any AWS users in the audience, and you're new to OpenStack, this is not an exhaustive list, but just kind of a sample list of how these pair up. One thing I will say is there isn't 100% feature parity between them. So AWS CloudFormation, every feature that it has isn't included in Heat, and Heat does some things that CloudFormation does not do. But for the majority of the functionality, it matches up. Again, it's not an exhaustive Rosetta Stone, but it gives you an idea that some of the things that you want in a public cloud are some of the things that OpenStack provides in a private cloud. So we talked about the core services. Here's kind of a listing of them with their names and their functionality. If I had this on like a flashcard my first summit, that would have been awesome. Because I just couldn't remember them. So Nova, again, it provides configuration and coordinates to the creation of virtual machines. It does. I mean, there are more functionality to it. I'm not going to read all of these, but just know that Nova is the compute engine. Block storage, again, is Cinder. Think Cinder block. provides persistent block storage resources to instances that they can consume. And again, there are some examples there for Azure and Amazon. Networking, Neutron. I always remember this one by Jimmy Neutron. He's flying around space in his little spaceship, right? He's a packet. And I don't know, that's my best guess, sorry. That's all I got for you. Glance, image service, right? You glance at an image. Again, it's used for uploading, discovering, and retrieving images that you use for your VM creation. Object storage, Swift. Now, this was one of the original projects that came into OpenStack. Why it was named Swift, I don't know. I'd have to ask somebody who worked at Rackspace. But sorry, I got nothing. Swift it's not Swift. It's eventual consistency, and maybe it was like a Swift idea. They said, man, that's a Swift idea. I don't know. I'm making things up now. Keystone, again, is the identity service. I used to like to think of this one as Keystone Cops, right? The guys with the big funny hats on, chasing robbers around. And it's really a good description because Keystone is called a lot of times throughout a provisioning session or any of the API calls. Keystone is the cornerstone of OpenStack. It's when it comes to authentication, authorization, and authentication. This is the conceptual architecture for OpenStack. As you can see, oh, wait a minute. How'd that get, wait a minute. Oh, that's Game of Thrones. Never mind, that's all the families for Game of Thrones. It looks a lot like the conceptual architecture of today's OpenStack, but it's not quite. Okay. There's one, right? This is a very simplistic one. Again, people say our OpenStack is very complex. I disagree. I think it's daunting at first, but I don't think it's very complex. I think if you look at it, it's got a dashboard, it's got network, compute, image, object store, block storage, identity, and they all work together. And they all work together in a very well-defined and consistent way. And you can see, this calls that. It's very, very consistent. So this is a very simple view of how most OpenStack services work. I'm going to get a little technical here, so just bear with me if you're not super technical. But there are stateful and stateless services inside of OpenStack. Stateful services would be a message queue, right? It can't be, they do have HAQs and RabbitMQ, but let's say that, for example, you don't run HAQs. You just have one service that's running your queues. If that goes down, or if that somehow gets corrupted, then there's a problem. Or you can switch to a passive instance or another active instance that's running. But let's just say for this example, this is a source of record for all of your queues. That would indicate that it's stateful. All of the other stateless service, another stateful service is the database. Yes, there are database replicas. You can run multi-master. A lot of people do, things like that. But it is a source of record for data, and therefore it's stateful. If it goes down, failing over to another one is, I'm not going to say hard, but they maintain state. So up, down, up or down, they have a state. The API services, though, they are stateless. So they just run. They have no state. Your API is not up or down. Your API service could be up or down, but the APIs are stateless. So when requests come into OpenStack, they come in through APIs, open APIs, and they do CRUD operations, create, read, update, and delete. And they can also communicate directly with other APIs in the environment. When these requests are completed, they go into the message queue. So when you get let's say a create request, via RPC, it goes into a message queue, and then is handed off to something like the scheduler. And the scheduler, Cinder scheduler, Nova scheduler, it makes intelligent decisions on where your resources will go, what pieces of hardware it should land on. Once it makes that decision, it passes those placement decisions off to the actual service itself. So Cinder volume, libvirt or QEMU, passes them off to the compute portions of it, and then they go to the driver or plugin for where they're to land. So let's say, for example, Cinder, the block storage. Cinder scheduler says it looks like there's storage over here on this piece of storage equipment, so appliance, let's say. It then uses, let's say, I'll pick on a storage company, NetApp, let's say NetApp. It loads the NetApp driver and communicates directly with the NetApp storage, creating the volume on NetApp, and then sends back a status, which then goes back to the API and shows that the request was completed. So just very quickly, into the API, into the queue, out of the queue, into the scheduler, from the scheduler into the service into the message queue, and then out into the driver and plugin. If you think of the message queue like any other message queue, it's a traffic controller, right? We don't want to overwhelm the services directly by sending them 1,000 requests for something. So we need traffic control in these 3 different steps, and then it finally gets to the driver and plugin and provides the storage, compute, or network resource that you requested, or deletes it, or changes it, or updates it. This is how, in a very simple sense, how all the services work in OpenStack. If you know this, you will not be confused. Now, are there projects with multiple different services that communicate back to the queue and in different ways? Absolutely. There are all sorts of weird and wonderful things, but they all follow this same API flow. So if you haven't done it already, if you haven't attempted downloading DevStack or RDO PackStack, I'm going to go through this real quickly. We don't have time for a demo. Normally I would demo this, but these are the steps that you would do to get yourself some DevStack. It's a personal, let's call it a personal pan pizza, right? We talked about pizza. It's a personal pizza, OpenStack pizza, that you can run on your own laptop. You can run it on I've had it running on a Raspberry Pi, but I wouldn't suggest that. But, on your own infrastructure that's affordable, even on your own laptops, as I said, in a VM, and you can play with OpenStack to your heart's content, break it, blow it up, change it, do whatever you want. And when you do, and it's completely destroyed, guess what? You just delete the VM and load it again. It takes 25 minutes on a slow PC. People say OpenStack's hard to install. They used to say that. I don't hear it a whole lot anymore, but this is pretty much like very, very simple. I mean, it's very quick. I will say, do not do this for production. Your life will become very bad, and you will most likely get fired. So please do not put DevStack in production. You've been warned. Next part of it is you run stacked sh. You'll see a whole bunch of messages scroll by for about 20 minutes, and at the end, you will profit. And it'll say, this is your host IP address. Well, if you enable IPv6, you will have it, and then it'll tell you, completed in 1,149 seconds. Quick, do the math. How many minutes was that? All right, too slow. All right, so to test it, you basically load your OpenStack profile, and you list your hypervisor list. If your hypervisor lists, if this command comes out something similar to this, you win. You've completed an OpenStack install, and you're a master. You can apply for your DevStack master certification, if such thing would have existed. That same IP address, you surf to the web, you bring up whatever web browser you like, point it at that same IP address, log in with demo or admin. Your credentials would be in that OpenRC file. You log in, and you're there. You'll get a full-blown OpenStack. Now, will you be able to provision Oracle databases that run like missile codes? Yeah, no. You won't be able to do that. I don't suggest you do that on your laptop anyway. But you will be able to load basic apps, Cirrus images, CentOS, Ubuntu. You'll get them going in a minimal sense. I mean, depending on how big your laptop is. If you have a monster laptop, hey, have at it. Run WordPress in production. I don't care. All right. Whew, that was a lot. I have a few minutes for questions. So, 5 minutes for questions.
Is DevStack, is it standalone or can be clustered with different servers as well?
Yes. Answers to both questions is yes. It is a standalone, so it includes a number of projects, but in the DevStack configuration, you can add additional projects. So there is a more complex configuration file you can get into and add additional projects to test, besides the ones that just come out from the default install that I did there.
But my question is, let's say, for example, I have two laptops.
Mm-hmm.
I want to install DevStack here and there, and then make it a single.
What you'll end up with is two independent clouds. Now you can configure it to federate those clouds, but I would not use it. I would not use DevStack for that. I might use PackStack, the RDO version of DevStack. Come on, I left 5 minutes for questions. Usually I don't. I'm usually too slow. All right, right here. I can't hear you. Could you use the microphone?
With increased emphasis on security, maybe you could really touch where OpenStack as a cloud provider is to be, providing increased security and including certification.
Sure. OpenStack has its own security group that is constantly going through the OpenStack code, making sure that it checks out. They have their own advisory service where they send out advisories if there is any issues. The great thing about OpenStack is it's code that runs on top of other utilities and the OS. So unless there's something within the Python and associated Go code and in Django code, the problems tend to happen underneath OpenStack in the operating system, inside of the utilities that it's using to create these virtual resources. So if you're running it on Red Hat, you're going to see the patches come out from Red Hat. If there is a vulnerability in the actual code itself, the orchestration code, absolutely. They have their own security group that's on that, and there's mailing lists you can subscribe to, and they're constantly reviewing that. So yes. As far as certification, I can't answer that, but as far as the monitoring of security and security research, yeah, there is a group inside of OpenStack that's just dedicated to that. I heard Optane, stateful. Sure. As far as the stateful requirements, it's basically when you create your control plane, the servers that you put together, the hardware you put together, are the requirements that you will need based on the size of your cloud. So if you're using something like Optane or some of these high performance memory modules, of course it's going to take advantage of it. The underlying database, for example, that runs on most OpenStack installs is MariaDB. So if you could tune MariaDB to take advantage of Optane, then your whole cloud will then benefit from it. And as I said, OpenStack uses these underlying open source project or programs, binaries, to do what it needs to do. So when you're tuning your OpenStack, you're actually tuning these underlying open source programs. So same thing with the queuing, RabbitMQ. There's 1,000 ways to tune RabbitMQ, and again, as I mentioned, one of them is high availability queues, so that if you lose one of the RabbitMQs, you have HAQs, but then there's a price for that, right? There's a performance price for doing HAQs. So, there's a trade-off and everything, but it's so flexible. You tune it to what you want, how much HA you want, how much service assurance you want, how much disaster recovery protection you want. Mm-hmm. Yes, Linux. I am a friend to all OSs, so that's more of a religious argument. Whether if Ubuntu or Red Hat or SUSE are more performance. I've never heard anybody say that. Oh well, I ran my OpenStack on this, and the performance was horrible, and then I ran it on that, and it was fantastic. I think it's what a company's comfortable with. I will say, based on statistics, Canonical's Ubuntu, it has the majority of OpenStack installs running on it. Latest user survey, anyway. So that's a good question. So there are ways to hook Keystone into LDAP, AD, OpenID systems like Google. There are OpenIPA. There's OpenID. Yeah. What's the other one? Okta. Okta is another one that can integrate with. So yeah, you're not just relegated to using Keystone internal authentication. It's just one of the options. And then there are third-party things, third-party appliances, third-party programs that integrate with Keystone, so that use the Keystone API as an authentication end. EMC's storage grid. For the longest time, they were asking for that. The storage grid is the object storage appliance for EMC, the dedicated appliance. It then would use Keystone as an authentication source. So there are things like that are out there. All right, I think am I at my time? Am I done? Yep. All right. Thank you, everyone. I appreciate it. I know it was a lot, very quick. But I appreciate you coming. I hope you learned one thing. That's all I ask. Thank you very much.